So tell me a little bit about the scalability of the SDC.
So the SDC was built to scale. We understood from the beginning that because we approach the LTE PC market, what the needs that our customers, the service providers have today are only the tip of the iceberg, because we expect all of us the data growth and LTE adoption to continue on a positive curve, hopefully. And so the SDC was built in a way that it can scale what is called in the technical jargon N plus M. So you can put many chassis inside your cabinet, and they can scale in a linear manner. And we know to support on each braid today tens of thousands of transactions per second, which translate for millions of subscribers. And we can scale in the linear way to support the growth needs of the service providers.
So you mentioned that the SDC supports over 50 diameter interfaces at this point. Why is that so important to service providers?
I think it's important from two ways, from two main reasons. One of them is that the use cases that we see out there is that involve many times the DRA is required to sit in the middle of the network and to handle PCRF use cases and to handle OCS use cases and to handle MME use cases. And if he's not too busy, maybe handle a few of the soft switches also. So you're required not to focus on one area of the network, not only around the OCS or around the PCRF, but in many use cases you need to handle many different interfaces and functionalities. So this is one reason why it's important. I think the second reason is that the service provider knows that, okay, I have a problem around the PCRFs. There's a lot of signaling there. I'm an early adopter for LTE. I need management. I need a DRA. But I expect a problem to happen around the MMEs in the future, or around the HSSs, or around the OCS. So for him, it's good to know that there's a vendor here that can handle and solve these issues not only around the PCRF, but everywhere around the network. And that's part of our commitment, really. You know, we've been there in the forefront of diameter from the beginning. I think we show our commitment to our customers in the last 6-7 years. And we are here, and we intend to keep showing this commitment. And part of it is the technical leadership that we offer customers.
So roaming is a huge use case with service providers that they're very concerned about now. And there's a diameter edge agent that is responsible for meeting those needs. Can you tell me a little bit more about the SDC capabilities in that area?
Of course. So you are completely right. There's a GSMA standard for what is called diameter edge agent, DEA. And it sits in the edge of the network, and it handles all the connectivity between service providers. In the past, it was based on SS7, but with the move to LTE and EPC, it's moving to diameter. It's important to note also that the connectivity in the past was mainly between service providers, was mainly for SS7. There was limited signaling and limited needs. With the move to LTE EPC, the requirements from diameter are much wider. We are talking about data, not only voice anymore. We are talking about much more use cases. We are talking about new use cases, things like end-to-end policy. So HPCRF and VPCRF needs to communicate over diameter between vendors. We didn't have those use cases in the past. Voice was much easier to manage. And what the DAs came to do is really to handle all those use cases. One of the main challenges with DA is really that every vendor has his own diameter vendor. So some have Ericsson, some have NSN, some have LU, and the other usual suspects, and each one has his own diameter variant. And one of the requirements from the DA is the ability to do translation between the vendor specifics, between what is called the vendor specific AVPs, coming from each of the service providers in very high speed, and to make sure that they can come into the network without causing any failures and could be digested by the in-house network functionalities. So you, and of course, coming back to the originating network, you need to translate it back. So that's part of the challenges there. I will say also that today, almost with every DA deployment, there's a deployment for what is called IWF, interworking function, which is based on a 3GPP standard. The interworking function, it knows to translate between SS7 map to diameter. Why is it needed and why it's used together with the DA? The reason is today we are in the early stages of LTE, and many times service providers are required to enable roaming between LTE networks to legacy networks. The legacy networks are using SS7. The LTE networks are using diameter. So you need to translate between diameter to SS7 to enable roaming, and this is exactly what the IWF is doing. This is why sitting in the edge next to the DA, you will find almost always an IWF, an interworking function. Of course, we support both of them and have a lot of experience in this field.